So today's lesson is the second half of section 11.3. So 11.3 continued. It's our second half of our lesson on this. So our objective today is to analyze ellipses with the center at HK, opposed to what we did on Friday when we were analyzing ellipses with the center only at the origin. We're going to be using the same formulas in your notes from Friday, so you'll want to have a reference to those or be able to flip back and forth as we go through today's lesson. Our first example is to find an equation of the ellipse with a center at 2, -3, one focus at 3, -3, one vertex at 5, -3, and then to also graph. So similar to the directions I gave you guys on Friday, I would suggest just setting up your paper, kind of using that similar template that I showed you, where we set up a graph, we set up A, B, and C, and just kind of go from there, filling in the information. So I'm going to go ahead and start with an XY axis. Make a list of A, B, and C, and the corresponding A squared, B squared, C squared. And it looks like our ultimate goal is to find an equation and graph. So whenever we're given points, I would always suggest that you start by plotting what you're given. We're given a point, the center is at 2, -3. And I would highly suggest that you label these. One focus at 3, -3. And one vertex at 5, -3. So I can actually start filling in what A, B, and C stand for at this point. A is your distance from center to vertex. So if you go look at your graph, you can actually count spaces as long as you're graphing accurately. 1, 2, 3 would be the distance for A, meaning that A squared is 9. B stands for the distance from the center to the extra points, which I don't have at this point, so I'm going to go ahead and leave that blank. But C is the distance from center to focus, and if I count those spaces on my graph currently, I see that there is 1. So C squared would also be 1. We can go ahead and right now go find B squared. And that's B squared equals A squared minus C squared. So B squared equals 9 minus 1, which would be 8. So I go ahead and fill that in, meaning B is the square root of 8. Something else I would probably do, maybe even first before finishing my list of A, B, and C, is once I know where one focus and one vertex is, I know the ones that are corresponding on the other side. So I can go ahead and plot my additional focus and vertex just using what I know about symmetry and ellipses. So 1, 2, 3 to the right for one vertex, so 1, 2, 3 to the left for the other. And then if I get the square root of 8 for B, well, I know the square root of 9 is 3, so it's going to have to be a little under 3. So that means B gives me my extra points. I would have to go up 1, 2, 3, but actually not all the way to 3. And then 1, 2, 3, but back a little bit. You could also go ahead and put the square root of 8 into your calculator, find what that decimal is, and that will help you plot that as well. Looks like I'm ready to go ahead and finish up on my graph. So I'm going to go ahead and draw on my ellipse as best as I can. Probably not going to look too great. So there's our ellipse. The other thing I was asked to do is to find an equation. So something to consider before you start writing your equation is this a parallel to the x-axis or parallel to the y-axis kind of graph? You'll notice your center, foci, and vertices are all related to each other horizontally, so that would be parallel to the x-axis. The equation, if you look in your notes for that, was x minus h squared plus y minus k squared equals 1. And remember, both formulas that I gave you start out the same way. It would just be the denominators that are different. So I mentioned kind of a note to try to remember these is that if your major axis, so where your foci and vertices are, is parallel to the x-axis, that means your larger number, so a squared would have to be under the x. That means b squared would have to be under the y. If I go ahead and substitute in my values, this is where you're going to start to see something just a little bit different than what we saw on Friday, and that h and k are not only zeros. So if I just substitute in, h represents the x value of your center, while k represents the y value. So substituting in, move this so you can see it, it would look like x minus 2 squared over our a squared, which is 9, plus y, it would be minus a negative 3, so that would turn into a plus 3 squared over b squared, which is 8, equals 1. So some things about the equation I just want to make sure you really pay attention to. Notice that your x minus your h is squared, and the y minus k is squared. It's not the x and the y individually that are squared, but the quantity, so just be careful where you put your squared. Notice the a squared is under the x because this is a parallel to the x-axis kind of graph. Larger number goes under the x in that case. And notice there's no place for c squared in our equation, so don't try to fit it in somewhere. A couple other things is notice there's a plus sign. Ellipse always has a plus sign here, and our equation will always be equal to 1. So don't leave off the equal to part. It does need that equals 1 in order to be correct. So this is our equation based off of the given information. And then we also have the graph that corresponds with it. So hopefully you'll notice this is really almost, exactly the same thing we did on Friday, just we're noticing our centers not 0, 0. But all of our spacing and counting and relationships are going to still be the same. So let's go ahead and do another example. So example 2, we're being asked to analyze the equation, which means instead of starting with information about the graph, we're starting with the equation, and we'll have to break that down to find some information about the graph. And also find the center, major axis, foci, vertices, and the graph. What I want you to notice about this equation is hopefully just kind of by looking at it, it doesn't look really anything like those equations we've seen so far. So there is a technique we're going to have to use in order to get this equation to become in the form that we need to recognize the A, B, C, the center, all of that good stuff. And that is to kind of do some grouping and some completing the square. So let me walk you through that. The first thing you want to do with an equation in this current form is to actually rewrite it so your x's, or terms with x's, are next to each other, your terms with y's are next to each other, and your constant has been moved to the right side of your equation. So what I'm suggesting would be to rewrite this as 4x squared minus 8x plus y squared plus 4y. And then I'm going to set that equal to a negative 4. So this positive 4 on the left side has been subtracted from both sides and is now on the right side. The next thing you want to do once you've kind of grouped just by location is actually group using parentheses. So I'm going to group my x's together and group the y's together. And now I'm going to have to go through the process of completing the square, not once but actually twice, once for the x's and once for the y's. So in order to do completing the square, we do need a leading coefficient of 1. So I'm going to factor this 4 out, leaving me with x squared minus 2x. I will leave space within the parentheses, a reminder that I need to complete the square, plus notice our coefficient of the y squared is already a 1, so I don't need to factor anything from there just yet. It'd be y squared plus 4y, and leave some space, still equal to negative 4. Okay, so as a reminder for completing the square, what we do is we evaluate b divided by 2, and then we square that quantity, and that is the term that gets added into this parenthesis, multiplied by the 4, and added to the right side as well. So b for the x's is a negative 2. And if I divide that by 2 and square it, I end up with a negative 1 squared, or just a 1. So I'm going to take that number 1, add it inside with that parenthesis to complete the square. but also need to balance out my equation by adding something that is equivalent on the right side. What I want you to be careful about is notice that this is not actually just a 1. Because of its location inside this parenthesis, it's really a 1 times 4. So kind of like the weight that it carries on this side of the equation is not just that of a 1, but of a 4. So to balance this, I actually need to add 4 to the right side. So again, I add 1 here, and I get that by using b over 2 squared. But before I add it to the right side, I need to multiply it by the 4 because that's actually the value of that number. And I add that to the right side. Now to complete the square for the y's, I would do the same thing, b over 2 squared. In this case, it would be 4 divided by 2 squared, giving me 2 squared, or just 4. So I add that inside here. Notice for the y's, there's not a coefficient out in front of the parenthesis, so I don't need to multiply it. If I can, it's just like multiplying by 1, and then I add a 4 to the right side. The next step, after you've completed the square, remember our goal there is to create what are called perfect square trinomials within these parentheses, is now to factor. So I leave the 4 out in front, but I'm looking for a way to rewrite my equation in this form. And it looks like on the right side, -4 plus 4 plus 4 would just give me a 4. So what do I factor x squared minus 2x plus 1 into to give me this parenthesis squared? Well, it multiplies to 1 and adds to -2. Well, that would be a -1 and a -1. And I did try to point this out to you when we reviewed completing the square before, that if you go back up to our work, b over 2 before we actually squared it is the same number that shows up in our factoring here. The same would be true for the y's. What multiplies to 4 and adds to 4, and that would have to be a +2 and a +2. So now hopefully you're seeing that this is looking a lot more like the equation of an ellipse, but an equation of an ellipse needs to equal 1. So I'm going to go ahead and divide every part of my equation by a 4. Leaving me with x minus 1 squared plus y plus 2 squared over 4 equals 1. Noticing that here, the 4 over the 4 would reduce to a 1. Something that may help you but is not necessary is to write this over 1. So if it kind of helps you determine our next step with the a's, b's, and c's, you might want to write that over 1. So now I have an equation. It kind of feels like a lot of work, I know, but once you practice that a little bit more, it'll get faster. This is the actual equation I'm going to analyze. So if I want to analyze and graph this, I'm going to set up my paper with my XY axis. And then I'm going to make a list on my paper for A, B, and C. A squared, B squared, and C squared. And then I'm also going to want to list the center, the major axis, the foci, vertices to go along with that. Okay, so looking at our equation, hopefully you can see, first thing I would probably do is list my center. What you're going to need to do is remember that you're going to take the opposite signs from these values here. So your center would be at 1, -2. The x value comes from what's with the x, the y value from what's with the y. Be very careful here. These may be out of order sometimes, but it doesn't mean that just the first number goes with x. It's the number that's actually added or subtracted from the x. That would be your x value for your center. Major axis you would get by looking for your larger number. I notice out of my denominators I have a 1 and a 4. 4 is larger, so that must be my a squared. And where my a squared is helps me know what axis this is parallel to. So if my a squared is underneath the y, I know my major axis for this is actually the y axis, and that would be the axis that it's parallel to. I'm going to hold off on my foci and vertices until I actually have my graph drawn. To find a, or I should maybe start with a squared, it would be the larger of these two denominators, meaning that it's 4. A would then be 2. B squared is the smaller of my two denominators, so it would be 1, meaning B would be 1. And then I would need to maybe do a little bit of work to calculate C squared. So I have the relationship that B squared equals A squared minus C squared. This would be -3 equals -C squared, or just 3 equals C squared. And C would be the square root of 3. So I can go ahead and finish up my graph now. So we'll start and finish up my graph and then label my foci and vertices after. So my center's at 1, -2. Now, when I go to graph, I would probably just go in order of A, B, and C. A standing for the distance from the center to a vertex. And knowing that this is supposed to be parallel to the y-axis, I'm not going to put those on the left and the right side like we've kind of done a lot of more examples of that in the past. These are going to need to be above and below the center. So I go 2 up from my center for one vertex and 2 down for the other. B gives me the distance to my extra points, which should be opposite directions from my vertices. So I would have 1 to the right and 1 to the left. C being the distance to my foci. The square root of 3, knowing the square root of 4 is 2, it must just mean that it's a little bit less than 2. So I'm going to put my foci inside. Draw this in. Remember, your foci should be on the inside of your ellipse. Don't kind of leave them floating on the outside. And then if I want to actually list my foci and vertices, the vertices are pretty easy spots to locate. Looks like I have a vertex at 1, 0. And I have another vertex at 1, that's 1, 2, 3, -4. For the foci, the easiest way to actually write this when you have a value that is not kind of like an integer, one of those nice easy numbers to work with, would be to start from your center and just realize that the x value for your foci is the same. So they both have an x value of 1, but their y values are either a value added where you've added the square root of 3 to go up, or you've subtracted the square root of 3 to go down. And the reason I'm saying square root of 3 is because that's the amount of your distance to your focus from your center. So I know my center is at -2 for a y value, and I'm going to write that I would have added and subtracted the square root of 3 to that in order to get my additional points. So you can write that as 2 points or just 1. But whenever you have a value that's not, what doesn't feel exact, it's exact, but it's not an easy to pinpoint point, I would go ahead and write it that way, where we're adding and subtracting the square root instead of using a decimal for those values. So there's example 2. And if you need to take a closer look at that, you can go ahead and pause that to take a look. And I'm going to go ahead and move on to example 3. What I would really suggest you guys do at this point is kind of pause the video as you guys are watching this. Take the information that's given and see if you're able to do this problem before you just look at my answer. That would be kind of your test to see if you really understand what you're doing instead of just copying what you're watching me do. But when we're asked to find an equation and to graph, given some starting information, I would start by graphing, or maybe just even setting up my paper. So let me get my paper set up with my axis. And then I'm probably going to need a list, A, B, and C. I'm sure I'm going to need to know my center in order to be able to write an equation. So you'll notice the information that we're given in this example is a little different than the other examples we've seen, but I can still start by graphing what I'm given. I have a vertex at 2, 5. And a vertex at 2, -1. The only other thing we're told is that C equals 2. What I'm hoping you guys realize at this point is when you know where your vertices are, your center is going to have to be halfway between them, just based on what we know about the symmetry of an ellipse. So if I count spaces, if it's not obvious to you already, 1, 2, 3, 4, 5, 6 spaces in between my vertices, my center would have to be 3 spaces in between. So 1, 2, 3. So even though we're not given what the center is, we can find it. I'm going to go ahead and list it kind of as I find it. Looks like that's at 2, 2. And then I also, even just based on the counting I did, can write down what A is. If A is the distance from a center to a vertex, and I count those spaces, 1, 2, 3, or 1, 2, 3 down, A must be 3 and A squared is 9. The other piece of information is that I'm given that C equals 2. Please be careful, that's a lowercase c representing the distance from the center to a focus. It's not representing the center. So if I know center to focus, I can go ahead and plot that. The distance is 2 up and 2 down. And the reason I would know that it's up and down is that your foci need to be in line with your vertices in your center. Looks like the only thing that's missing in order for me to find my equation and to finish the graph would be to figure out what B and B squared are. So if I know C is 2, I should write that in. C squared is 4. I can use what I know about A squared and C squared to find B squared. B squared equals A squared minus C squared. So B squared is 5, and B would be the square root of 5. Square root of 5 would be, let's see, square root of 4 is 2, so it's going to have to be a little bit larger than that. And that would be enough to draw in my graph. Last thing I would need to do is write an equation. Before I start writing my equation, I would probably look back at my notes. Notice that this is a graph that's major axis is parallel to the y-axis. So my formula I'd be going from would be x minus h squared plus y minus k squared equals 1. And if you notice kind of how I get this set up, then I ask myself, where should the a squared and b squared be located? Well, if my major axis is parallel to the y-axis, I'm thinking that my larger number needs to be under the y. And by larger number, I mean out of a squared and b squared, meaning a squared would have to be under y and b squared under x. And you can just go back to your notes to kind of get that information from there, but thinking through that process is what you're going to need to do when you don't have your notes in front of you. So now that I have all the information, I go ahead and substitute the numbers into my equation. It would be x minus 2 squared